Okay, good morning class. So at this point we're looking at probability. We're reading from page 305 out of your Mind Action Series textbook. Okay. And I didn't tell you that we will be starting this topic today, so from Monday onwards you can bring your textbook with. Okay, a very fairly short topic. Takes us about 4 to 5 lessons. Okay. So we're looking at probability. Summary of probability theory from grade 10 and 11. Okay. We have said consider the probability rule with the probability of A or B, or A or B can also be noted by union. Not so? And then and can be indicated with intersection. Okay. So we got union and intersection there. So we are told that consider the probability rule, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, we don't want to account for A and B twice. That is why we take it once off. Okay. A and B are inclusive if A and B is not equal to 0. Which means to say if A and B is not equal to 0, that means to say there is an element that belongs to A and B. You guys understand? In set A and set B. There is an intersection. So this is what they're talking about. This is inclusive. Okay, you see that B is part of set A and B is part of set B. Can you see that? That is why when we take it off by saying the probability of A and B, you're taking one of it off. Okay, so we're taking one of it away because it's in both sets. Okay. Then we are told the probability of A and B with G on the outside. It's the same example here. There's just the G's on the outside. A and B are mutually exclusive, which means to say there's no element that belongs to A and B. Can you see that? So if they say your sets are mutually exclusive, then the probability of A and B is 0. Okay, you must memorize that. Okay. There is no intersection, and there is the example there. For mutually exclusive events, the probability of A or B is equal to the probability of A plus the probability of B. So I don't have to take anything from it. Exhaustive events contains all the elements of all the sample space between them. In case of A or B is 1, and A or B is 1. Can you see there is nothing on the outside here, which means to say there's no element that doesn't belong to A nor B on the outside. Can you see that? That we say is exhaustive. Okay. Complementary events. Complementary events are mutually exclusive and exhaustive. In this case, the probability of A plus B will give you 1. Can you see that, people? If you add your sets up and it gives you 1, then that's now your pure probability. So again, your complementary events, if you add your sets together, it gives you an answer of 1. So that is complementary. We'll speak a lot about that later on. Okay, the sets with the set A, not B, is B. The set not A is B. Can you see that? Not A. Normally we indicate not A with that thing on top. Not so. So here they say the probability, the set not A is B, since all the elements that is in A.
My apologies for the interruption. All RCLs can please report to room 49 immediately. All RCLs to report to room 49 immediately.
The RCLs here? No, okay, no problem. So we can write not A equals B equals not A. We can write not A. Yeah. These are 3 ways that you can write it. Okay. As I indicated, not A is basically that. Okay. The thing on top also means not A. Number 4, the events A and B are not complementary. Not complementary, then the set not A will be different to B. Can you see here? So you say not A, so you're covering A, so it's basically what you are left with. But you can't say, so not A, not A, so he's basically covering this. Can you see that is not equal to B? Why? Because our G is on the outside. Can you see that, people? If G was not on the outside, then that would have been not A is equal to B. You said B. You guys understand? Right. So that's that. And that is also not A. So, yeah. Alright. So that basically brings us to the revision exercise of grade 11. Okay? So I take it you all were doing your work in grade 11. We came to probability. That is homework for Monday. I'm sorry, for Wednesday. No? There's no school on Monday. Please don't come to school. Yeah, I'm not going to be here. Okay. So your revision exercise is for Wednesday. New heading, the fundamental counting principle. This is now grade 12. What? The fundamental counting principle. You can write that note. Consider the situation where you flip a coin, then roll a die. We'll speak about this now. Pause the video at this point as well. Alright, so here we are told the fundamental counting principle. Consider the situation where you flip a coin and then roll a die. You guys know what a die is, no? Yes, a dice. We call it dice, but one die. Many dice. There are 12 possible outcomes in this situation. Not so. It can either be a heads over 1, a heads over 2, a heads over 3, a heads 4, a heads 5, a heads 6, or tails 1, 2 tails 6. Not so. So there are 12 outcomes. For the coin there are only 2 possible outcomes, whereas for the die there are 6 possible outcomes. Therefore, you can state that there are a total of 2 times 6 equals 12. Total possible outcomes. A shortcut approach is called the fundamental counting principle and can be stated in general as follows. We write the rule 1 down. Okay? You put it in a box. Okay? That is the rule 1 for the fundamental counting principle. If one operation can be done in M ways and the second operation can be done in N ways, then the total possible number of different ways in which both operations can be done is N times N or M times N. Alright? Again, I'm going to pause the video at this point. Alright, so with that, a fundamental rule that was said there, if you apply to what we have here, what you'll see me do is, if I take this example into account, okay, what you'll see me do is I'll draw bids like that, 2 bids, okay, why? Because there is a event of tossing a coin, bid 1, and rolling a die. You don't have to draw this bids now. This gives me a better visual understanding of what's actually happening. Okay. So how many outcomes are there for tossing the coin? 2. How many outcomes are there for rolling a die? 6. The 2 times 6 is 12, and that's what we have. You all okay with that? Right. Let's look at example 1. Example 1, and this is on page 307, I think. 307. Let's check here. Example 1. 308. Okay. Example 1, page 308.
So why is it 2 times 6 and not 2 plus 6? Or 2 minus 6?
Because if you look here, okay, we look here, this is actually the outcomes. That's the actual outcomes you can do. It's either a heads a 1, a heads a 2, a heads a 3, a heads a till the heads a 6, Or it can be tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. If you count how many are here, how many are there? 12 and not 8. That's why we move. Okay. In all the situations you'll see that's what we come out to. Okay. People, example 1, and this is on page 308. Example 1 on page 308. A meal can be made up as follows. Choice 1 is meat, fish or chicken. Choice 2, mash, chips, baked potato, rice or vegetables. Have you, my kind of person, then we're going to have fish and chicken in one plate with mashed potato and chips, no? That's why we look like we look today. Right. But under normal circumstances, you guys must know. You're not on my type. So you're either going to have meat or chips, or fish or potato, whatever. Okay? So that is how we're counting. How many different meals can be made up using these choices? So how many birds do you think we're going to have? We're going to have 2. Why? 1 for choice 1 and 1 for choice 2. Not so. How many options do I have for choice 1? Sorry? 3. How many options do I have for choice 2? 5. Not so. So how many ways or how many different meals can be made up? 15. Very simple, no? There's 15 meals that can be made up. Okay, so let's see. You got meat. It can be meat, mash, meat, chips, meat, baked potato, meat, rice, or meat, veggies. Fine. With meat. Not so. Then fish. Is fish mash, fish chips, fish baked potato, fish rice, or fish vegetables? Again, for fish, you're going to have 5. Can you see that? For chicken. So chicken is going to be chicken mash, chicken chips, chicken baked potato, chicken rice, chicken vegetables. So we have again 5. Not so? Which makes it total 15. Again, that is the reason why we are multiplying 3 and 5 and not adding 3 and 5. Does it make sense, people? So there was 15 meals that can be made. You look at example 2. Example 2 on the same page? Yes. No. Right, I think we can carry on Wednesday, no? People, enjoy the long weekend. Don't forget the homework on Monday, no? Your homework is 2 on Wednesday. Enjoy the weekend and the rest of the day.